What is the low frequency input resistance, Ri, in kilo ohms for the amplifier shown at a specific temperature, 27 degrees Celsius? We need that for what we have right here, amplifier. We're given our RC, an RE, and a RB as well. We can use our IC, our beta, our VT as well. And we're to neglect the effect of bass with modulation. We're going to look at the notes linked below the like button on page 132, and then we're going to look at page 141. And that's because on page 132, we are going to find out that this is a common collector amplifier. And after finding that out, we are going to use that information to get the equation for our Ri. We're also going to possibly need these to solve for something inside of here. So looking at this, we can do the problem. Our Ri is going to be equal to our R pi. This is our first unknown. We don't know what this is, so now we can solve for it. From here, inside of our equations right here, we can see that our R pi is equal to our V1, and this can be divided by our IB if we move that over. Now if we plug some things in, because we don't have our V1 or our IB, we are going to get that we have an I over GM, and then our IB is going to be I over our beta. Now we have an I on the top and bottom, so we can multiply everything by 1 over I. So this is just going to give us a 1 here. And then we can multiply top and bottom by beta. And that's going to give us that our R pi is equal to a beta over GM. Now our beta is going to be equal to our 10. Our GM is unknown here, so let's solve for it. GM is going to be equal to, and there's a few different ways we can look at this. Now for this problem, because there's a different way we can, and we have looked at this, and that's on page I think 92 in the notes linked below the like button. But for this one, our GM is going to be equal to, since we have our IC over VT. When we're given our IC and our VT, we can just use these, and we don't have to use the page 92 notes where we have the square root of 2 times our K times W over L times our ID. That's if we have our ID. With this equation, we have our 265 times our micro divided by a 26 times a milli. Now, if we plug this into a calculator, we're going to get our GM is equal to approximately 10.4 milli. So we can take this and plug it into here, and that means that our R pi is going to be equal to, we divide both of these out, we're going to get approximately 19 kilo ohms. So that's the answer here. Now, we can take this and plug it back into our original equation. So our Ri is equal to, we have 19 kilo ohms plus our beta plus 1, so that's going to be 20. And then we have our Re, which was given to us as 0.6, and this is in kilo ohms as well. So if we multiply everything together and add everything, we are going to get a value of approximately 7.58 kilo ohms for our Ri. And if we're putting this into the answer box, it's just going to be 7.58. So that's how we would go about looking and solving for this problem.